will have a talk about binomial probability distribution, and I will solve a couple of problems. In binomial distribution, we have n trial. We experiment something n times. Probability of success is p, and therefore, because probability of everything is equal to 1, therefore probability of failure is 1 minus p. We define a discrete random variable called x, which is equal to the number of success in n trials. And now we want to experiment with this probability distribution. Look, success does not carry a value with it. We may call failure a success. For example, we may say the probability of getting D and F in a course is 20% and call it P. That name of success or failure does not carry a value with it. Suppose 8% of inmates in a large prison are known to be innocent. So probability of success here to be innocent is 8%, or in probability languages is 0.08. So now in a situation when probability of being innocent is 8%, we have looked into 25 inmates. And the problem asks, compute the probability in this group of 25 prisoners. We have 3 innocent. So n here is equal to 25 and x here is equal to 3. Exactly 3, not less than or equal to 3, not greater than or equal to 3. P equal 0.08, n equal 25, probability of x equal to 3. We will use an Excel function, binomial distribution, 3, 25, which is the number of trials, probability of being innocent, and 0 means exactly 3. If instead of 0, if we put 1, that means less than or equal to 3. But here it means equal to 3. We use the formula and we get something around 20%. Compute the probability that we will find at most 3. That means x is less than or equal to 3. Binomial distribution is a discrete probability distribution. It is not a continuous probability distribution. So x equal to 3 has a specific value in discrete probability distributions. But in continuous probability distribution like normal and uniform, probability of x to be equal to 3 is 0. Probability of x equal to 3 is 0 in continuous probability distributions like exponential, like uniform, and like normal. But in discrete probability distributions like binomial and Poisson, probability of x being equal to a specific value is not equal to 0. When we found it here, it was this much, but now it asks probability of x less than or equal to 3. We use the same formula, exactly the same formula, 3, 25, 0.08, but instead of 0, you place a 1 here, and that's it. And if we do that, it will come out 86, around 86%. compute the probability of at least 3. At least 3 means probability of x to be greater than or equal to 3. At least 3. Excel does not give us this probability. Excel can give us probability of x equal to 3, and it can give us probability of x less than or equal to 3. It will not give us probability of x greater than or equal to 3. But we know that probability of x greater than or equal to 3 is equal to 1 minus probability of x less than 3. Because probability of x greater than or equal to 3 and probability of x less than 3 is equal to 1. However, Excel does not give us probability of x less than 3. Doesn't give us something like this. And what does it mean, x less than 3? Because between 3 and 2 we have nothing. This is a discrete distribution which its outcomes are just whole numbers. Therefore, probability of x less than 3 in discrete probability distribution is the same as probability of x less than or equal to 2. In other words, probability of x greater than or equal to 3 is equal to 1 minus probability of x less than or equal to 2. This is because this is discrete. If it was continuous probability distribution, because probability of x equal to 3 is 0, then in continuous probability of x greater than or equal to 3 was 1 minus probability of x less than or equal to 3. Why? Because here probability of x equal to 3 is 0, but over there probability of x equal to 3 is not 0. You need to remember this, which is the difference between continuous and discrete probability distributions. Probability of x greater than or equal to 3 is equal to 1 minus probability of x less than or equal to 2, and then we put it into Excel formula and we get the result, we subtract it from 1, and that is the solution. We could have done this also. We could have said probability of x greater than or equal to 3 is equal to probability of x equal to 3 plus probability of x greater than 3. And then that would be probability of x equal to 3, and probability of x greater than 3 is 1 minus probability of x less than or equal to 3. These two are the same. That is what we did over there. And this is probability of x equal to 3. This is probability of x less than or equal to 3, and this is 1. This is solving the problem from different angles. As long as you understand the situation, all of these are correct. Henry Ford was concerned about a low retention rate for his employees. To alleviate the problem, he increased the salary of the daily workers. For any daily workers chosen at random, it was estimated that with probability of 20%, the person will not be with the company next year. What is the probability that we choose 4 workers and one of them is not with the company next year? Probability of x equal to number of employees being with the company next year. Probability is equal to probability of success, probability of this event is 20%. We have selected 4 employees. What is the probability that one of them leave the company? Quite straightforward. Use binomial distribution. This is x, this is n, this is p, and this is equal, not less than or equal. And if you put it into the formula, that is the answer. What is the probability? At most, one of them have left the company. Again, probability of x, at most, one of them left the company. So x number of people who have left the company should be at most equal to 1, probability of x less than or equal to 1. Let's say this is x, this is n, this is p, and this is less than or equal. What is the probability that at least one of them would have left the company? At least means probability of x being greater than or equal to 1. This probability is 1 minus probability of x being less than 1. And that is equal to 1 minus probability of x less than 1 is only 0. So that is how we compute this probability. Probability of x greater than or equal to 1 is equal to 1 minus probability of x equal to 0. As simple as that. So we can put here binomial distribution less than or equal to 0 and 1 here. This will lead less than or equal to 0, and here equal to 0. Because binomial distribution before 0 does not have anything else, less than or equal to 0 and equal to 0 lead to the same thing. And then probability of x being greater than or equal to 1 is equal to 1 minus one of these two, which are equal to each other. In 10 multiple choice question, each with 5 answers, what is the probability that the student, all by guess, get at least 60%? So this is P, which is equal to 0.2, N is equal to 10, and then we just put it into the formula. It is 0.2 because we have 5 answers. Probability of everything is 1. Each of those 5 answers will get 1 over 5, which is 0.2. Here, 60% correct. We want to find the probability of x being greater than or equal to 6 because there are 10 questions. Probability of x greater than or equal to 6 is 1 minus probability of x less than or equal to 5. This is because binomial distribution is discrete. If we were talking about, for example, normal distribution, probability of x greater than or equal to 6 is equal to 1 minus probability of x less than or equal to 6, not 5. Less than or equal to the same thing, because in continuous probability distribution, probability of x being equal to something is equal to 0. Okay, read the problem and solve it. P here is equal to 0.04, which is probability of damage. N is equal to 75, and here the problem is asking at least 5. So probability of x being greater than or equal to 5. That is equal to 1 minus probability of x being less than or equal to 4. This is exactly what I have written here. Probability of x less than or equal to 4 is here. This is x. This is n. This is p. And 1 is for less than or equal. 0 is for equal. And x will give us that. I need to subtract it from 1, and that's it. This is the problem. Okay, here I want to explain what is mu for binomial distribution and what is sigma. Mu, sigma, average, standard, deviation. You should always remember that coefficient of variations is standard deviation divided by average. You need to remember this. And you should also remember that standard deviation is equal to square root of variance, or variance is standard deviation squared. In binomial distribution, mu or average, this is equal to NP, and variance is equal to NP times 1 minus P. Therefore, standard deviation is equal to square root of NP times 1 minus P. And coefficient of variation is standard deviation, which is square root of NP times 1 minus P divided by P. Therefore, average mu is equal to NP. Here we have 400 visitors times 0.2, it is 80, and then variance or standard deviation square is NP times 1 minus P, 400, 0.2, 0.8, and that is 64, and standard deviation is square root of that, which is 8.